Okay, welcome back. All right, so we just looked at series. We looked at n factorial x to the n, and that did not converge anywhere except for at x equals 0. We looked at 1 over n factorial x to the n, and that converged everywhere. Let's sort of go in between. Okay, let's look at n x to the n. So this wasn't my original example, but I like it as well. And it'll tie into something later on anyways. So, well, it's actually 0 to infinity, technically. N x to the n. Now, one thing I want you to notice, I'm sort of just kind of keeping this in mind, this is actually equal to, from 1 to infinity, n x to the n. Because when n equals 0, this is just 0, right? So, okay. All right, let's take a look at the radius of convergence via the ratio test. So again, our a sub n is n x to the n. Okay, so the limit as n approaches infinity. Did I say I'm using the ratio test? Yes. Here. I did not say it here. Sorry for those of you. Okay, and we're going to do it yet again, so I will just copy and paste that. Show the extent of my laziness. Okay, so we're going to use the ratio test yet again. We're going to take the limit as n goes to infinity of a sub n plus 1 over a sub n. Okay, so that's going to equal the limit as n goes to infinity, n plus 1 x to the n plus 1 divided by n x to the n. Okay, so that equals the limit n goes to infinity. We're just going to get n plus 1, right? Times absolute value of x. Well, that's just going to be the absolute value of x because as n goes to infinity, this n plus 1 over n is going to go to 1. So when does this converge? This converges if the absolute value of x is less than 1. Okay? And it diverges if absolute value of x is bigger than 1. Okay? And we're not going to, well, I mean, if x is equal to plus or minus 1 here, it's not going to matter. We can actually do that. Let's do that. So if x equals 1, then what do we get? We get the sum, n goes from 0 to infinity, of n. That's divergent for sure, right? And also for x equals negative 1. Sorry. Sorry for writing cursive there. We're going to get the sum, n goes from 0 to infinity, negative 1 to the n, which is still divergent, right? Because the alternating series, the term should still go to 0, each individual one. Okay, so those are both divergent. Okay, let's look at another one, sort of a similar one. It's going to be in this category 3. Okay, let's take a look at the sum n goes from 1 to infinity, negative 1 to the n, x to the n, over the cube root of n. Okay? Now, we're gonna look for the radius of convergence. We're gonna do it via the ratio test. So ratio test yet again. Okay, remember, the ratio test, if that limit is less than 1, your series converges. If that limit is bigger than 1, it diverges, and it doesn't say anything at 1. Okay? So we're going to take the limit as n goes to infinity, a sub n plus 1 over a sub n. Our a sub n is here negative 1 to the n, x to the n, over cube root of n. Okay, so we're going to get the limit. N goes to infinity. Negative 1 to the n plus 1, x to the n plus 1, cube root of n plus 1. Okay, and then divided by, we're going to flip the a sub n because it's in the denominator. So cube root of n, negative 1 to the n, x to the n. Okay, a lot of that stuff cancels. Okay, we're going to end up with limit as n goes to infinity. The negative 1, I'm just taking the absolute value of it. So I'm going to get absolute value of x times cube root of n over n plus 1. As n goes to infinity, that just goes and becomes absolute value of x. Okay, so again, this is definitely going to converge for absolute value of x less than 1. Definitely going to diverge for absolute value of x bigger than 1. Okay, let's look and see what happens at positive 1 and negative 1. Okay, if x equals positive 1, we get the sum, n goes from 1 to infinity, negative 1 to the n, cube root of n. This is an alternating series, right? Okay, our b sub n is 1 over cube root of n. That's going to be decreasing. And the limit, sorry, let me put that over here. The limit as n goes to infinity of b sub n equals 0. So this is a convergent alternating series. Okay, what about if x equals negative 1? X equals negative 1. Not forget this is our series. Okay, negative 1 to the n times negative 1 to the n. For 1 for the, in the definition, 1 for x being negative 1. That's going to be the sum, and goes from 1 to infinity, just 1 over the cube root of n. That is a divergent p-series. Okay, so let me make all of this just a little bit smaller to give me more space. Or actually just move it up. So in conclusion, my series, my power series, converges on, well, it does not converge, sorry about that. It does not converge at -1, but it does converge at 1. Okay, so here with the bracket, I'm indicating that at 1 it's convergent. At -1 it's not. Okay, all right. See y'all in the next video.